exploration of Mars is not going to happen overnight. It'll be part of a much larger program. And how do we sustain something?
Since ancient times, people have been fascinated by the stars, curious to know more about the universe's hidden truths. However, our journey to explore the vast unknown has been far from easy. It has been a challenging endeavor that has pushed us to our limits and required tremendous effort and determination. In the face of difficulties, we had bold dreams. We didn't allow gravity to hold us back, and we embarked on an incredible adventure that took us far from our usual home. Many brave people came forward, pushing limits and motivating our collective desire to achieve great things. But the universe is vast and unforgiving. It tests our resolve at every turn, demanding sacrifices and unwavering dedication. We experienced losses and faced setbacks along the way, which tested our determination and pushed us to our limits. But despite these obstacles, we always managed to find the inner strength to persevere and bounce back, ready to continue our journey. Through many nights without sleep and unwavering efforts, we conquered the impossible, getting closer and closer to the stars that called to us. But our strong thirst for knowledge cannot be held back. We had a deep longing to go beyond our own planet and discover distant worlds. It was like a fierce fire inside us, driving us forward and inspiring us to aim for faraway planets. As the moon, which is 4,400 kilometers away from us, has been the target of several human missions. The Apollo program, initiated by NASA in the 1960s, successfully landed astronauts on the moon 6 times between 1969 and 1972. The most famous mission, Apollo 11, allowed astronauts Neil Armstrong and Buzz Aldrin to become the first humans to set foot on the lunar surface. As we set out to conquer Mars, a sense of sadness fills our hearts. The tremendous distance that separates us from our goal weighs heavily on our minds. Mars, a faraway planet located 54.6 million kilometers away, presents a daunting challenge. With our current technology, it would take us 6 to 9 long months to reach there. The reality of this distance saddens us, but it also strengthens our resolve. We hold on to the hope that our determination will overcome this immense hurdle and lead us to triumph. As we strive to reach Mars, a daunting journey of 54.6 million kilometers that could take us 6 to 9 months, we cling to a ray of hope in the advancements of technology. Emerging technologies, like artificial intelligence, may hold the key to unlocking faster pathways to Mars. While uncertainties remain, our confidence in the capabilities of AI fuels our determination. As we embark on our journey into the unfamiliar, we have faith in the power of technology to make faster travel to Mars possible. We believe that advancements in science and engineering will help us reach the red planet more quickly and efficiently. But just getting to Mars won't be the end of our troubles. We'll have a whole new set of problems to deal with once we arrive there. On Mars, the atmosphere is predominantly composed of carbon dioxide and lacks sufficient oxygen for humans to breathe. This presents a major challenge for potential human colonization. One possible solution is to introduce a process called terraforming, which involves altering the Martian atmosphere to make it more breathable for humans. This can be done by releasing gases that can contribute to the creation of a thicker atmosphere and converting carbon dioxide into oxygen. For instance, scientists could utilize photosynthetic bacteria or plants to produce oxygen through biological processes. Additionally, technology like electrolysis can be used to extract oxygen from the Martian soil, known as regolith. The process of terraforming, however, would be a long-term project, potentially taking centuries or more. But another significant problem we will encounter is the extreme cold temperatures on Mars. Mars experiences extremely low temperatures, with an average surface temperature of around 80 degrees Fahrenheit, 62 degrees Celsius. This poses a challenge for human survival and the functioning of equipment. To combat the cold temperatures, habitats and structures on Mars would need to be well insulated to retain heat. High-quality materials with excellent insulation properties would be crucial to minimize heat loss. Additionally, heating systems could be installed within the habitats to maintain a comfortable temperature for humans and to prevent critical equipment from freezing. Once we manage to overcome the extremely cold temperatures, we will be faced with another problem: the limited access of water on Mars. Having water is vital for life, but Mars has very limited liquid water available. While there are frozen water resources in the form of ice caps and underground deposits, extracting and accessing them poses significant difficulties and obstacles. Various methods can be employed to obtain water on Mars. One approach involves melting subsurface ice by using heat from a power source or solar energy. Another possibility is extracting water vapor from the atmosphere through condensation. Once water is obtained, efficient recycling systems would be necessary to minimize wastage. Technologies such as filtration, purification, and advanced recycling systems would play a vital role in ensuring a sustainable water supply for humans on Mars. Unlike Earth, Mars lacks a global magnetic field, which exposes the planet's surface to harmful solar radiation and cosmic rays. This radiation can be detrimental to human health. To keep ourselves safe from radiation on Mars, we need to create habitats and structures that can shield us effectively. This can be done by using materials like thick layers of soil, water, or special shielding materials that can absorb radiation. It's also helpful to design habitats partially underground or include additional structures that act as shields against radiation. Growing food on Mars is challenging due to the harsh environment, lack of fertile soil, and limited resources for agriculture. To address the issue of food production, controlled environment agriculture techniques would be employed. This involves growing crops in controlled environments such as greenhouses, using artificial light, temperature control, and nutrient-rich solutions. Hydroponics, a method of growing plants without soil, can be utilized to conserve resources and maximize efficiency. Additionally, research into genetically modified crops that can thrive in Martian conditions may help enhance food production in the long run. After overcoming all these problems, humans will finally begin their journey to our next home, the Red Planet.